Okay. Solving logs. We talked a little about this when we were graphing logs and transforming them, just how the relationship is. So if some base to an exponent is equal to y, and we need to relate it to the logarithmic function, this is our y. Our a becomes the base of the log, and our exponent is what everything's going to be equal to. Okay, so that's how the relationship kind of works between each other. So use definition of an algorithm to determine the value of each expression. So they've given us a couple questions here, one of them being log 4?
64, yeah.
So base 4, 64. Great. Okay. Is equal to some value, right? And what we'll do is we'll relate it to x. It's equal to some value x. We don't know what it is. They tell us not to use our calculator for this. So what I'm going to do is I'm going to convert this log back to an exponential function. Well, what happens here is this is our a value, in other words, the base of our exponent, and this is our final answer of the exponent. So in other words, and again, what it's equal to is that's the exponent itself. So the way this merges is it becomes 4 to this exponent is equal to 64. So we really have 4 to some exponent is equal to 64. Well, we can kind of think that through. 4 to the power of 2 is 16. 4 to the power of 3 is going to actually give us our 64. So in that case, 4 to the power of 3 is equal to 64. Or sorry. All right, what I'll do is I'll write 4x is equal to, and I'll rewrite 64 as 4 to the power of 3 because they're equivalent, which then means, these bases you can kind of get rid of, and x is equal to 3. Okay, let's see if we can't quickly run through another. Another one would be like log, they've given us log 3 to the 1 over 27, right?
Yes.
Okay, 1 over 27. Well, that gives us a base. That's going to be, 3 is going to be our base of our exponent. So we have 3 is equal to some exponent is equal to 1 over 27. Well, right away, because it's 1 over something, I have a pretty good idea that I'm going to be working with a negative exponent, right? Because negative exponents are what flip our bases. So what I'm going to do is I'm going to turn this 27 to the exponent of negative 1, right? These two are still equivalent. 1 over 27 is still the same as 27 to the negative 1 x. Okay, well now what I'm going to do is I'm going to focus on the actual bases, 3 and 27. Well, 27 can be written as a base 3, 3 to the power of something. 3 to the power of 2 is 9, 3 to the power of 3 is 27. So I'm going to replace 27 with 3 to the power of 3. So we have 3x is equal to 3 to the power of 3 times technically that negative 1.
This is because it's a fraction, right?
Yes, because it was a fraction, yeah. The power of 3 to the negative 1, this is a power of a power, so we get 3 to the negative 3. So in other words, x is equal to negative 3. Anything else like that? And you pretty much go through them that way. That's the idea here.
How about square root?
A square root? Okay, so let's see a square root. They've given us log 5 to the cubed root 25 is equal to x. Okay. Well, we already know from our rules that our base will be 5, our exponent will be x, and it is equal to the cubed root of 25. Okay, I'm going to write that as a radical instead. So instead of writing it as the root, I'm going to write it as a power, but as a fraction. Do you know what that is as a fraction?
5 times 5.
Well, yeah, okay. The base is fine. I mean the root. Well, I'm specifically just talking about the third root of 25. How do I write that as a fraction? 1/3. So that's 25 to the 1/3. Okay, so I've gotten rid of the root. Great. Focus on the bases. 5 and 25. Well, I can write 25 as a base 5. It's what? 5 to the... Pardon?
Oh, 5 to the power of 2.
5 to the power of 2. Great. So I rewrite this. This becomes 5 to the power of 2 times... So it's a power of a power. What do I do with those two powers?
Multiply them?
Yep, so we get 5 to the power of...
2 to the power of 6. 3. Oh.
2 over 3. Right? They're multiplying fractions. In other words, 5 to the x is equal to 5 to the power of 2 over 3. So in other words, x is equal to 2 over 3.
Wait, what happened to the 5?
Well, this is already base 5, and this was base 5, so we kind of dropped them off,
Oh.
and we just focused on the x and the exponent. So x was equal to 2 over 3. Does that make sense?